Good afternoon. A very warm welcome to all of you. This is a distinguished lecture series, the 16th lectures from prominent professors, brought to you live by Faculties of Engineering, University of Technology, Malaysia. For your information, this distinguished lecture series is a lecture series by prominent professors, researchers, scientists from all around the world to discuss the latest technologies and issues, as well as exchanging expertise and ideas. And you are with me, Dr. Henry Kang. I'm the Director of Marine Technology Centers, Faculties of Engineering, UTM. Today, we are very pleased to have Professor Muk Chen Ong from University of Stavanger, Norway, with us. Professor Ong will deliver a talk on ocean technology, trends and challenges, and research activities at University of Stavanger. Let me leave the floor now to Professor Dato' IR Muhammad Rafiq bin Abdulkadir, Dean of Faculties of Engineering, UTMs, to give an opening address as well as introduce our distinguished professor. Prof. Rafiq, thanks.
Thank you so much, Henry. Assalamu alaikum and hello. Welcome, everyone. Welcome to our 16th UTM Engineering Distinguished Lecture Series. My name is Muhammad Rafiq and I am the Dean of Engineering, University Technology, Malaysia. Today, it is my utmost pleasure to welcome Professor Muk Chen Ong from University of Stavanger, Norway. A bit about our presenter today. Muk Chen Ong is a professor in marine technology and marine operations at University of Stavanger, UIS, Norway, and a member of Norwegian Academy of Technological Sciences, NTVA. He is currently Strategic Research Area Leader for Ocean Technology Innovation Cluster Stavanger, UIS EU Project Positioning Coordinator for Ocean Technology, and Head of Marine and Subsea Technology Group at UIS. He is also a key researcher in Norwegian Research Centre for Offshore Wind Technology, NOWITECH. He has published over 140 international journal and conference papers. He is an associate editor of ASME Journal of Offshore Mechanics and Arctic Engineering, an editorial board member of Proceedings of the Institution of Civil Engineers, Maritime Engineering, an editorial board member of Journal of the Korean Society of Fisheries and Ocean Technology, and an editorial board member of Ocean Systems Engineering, an international journal. He is also scientific committee members in International Conference on Ocean, Offshore and Arctic Engineering, OMAE, International Conference on Scour and Erosion, ICSE, and Conference on Computational Mechanics, MekIT. His research interests are dynamic analysis of offshore fish cages or net, marine lifting operations and installations, dynamic analysis of offshore wind turbines, vortex-induced vibrations, CFD with turbulence modeling, flows around marine pipelines, wind turbine foundations, ROVs and subsea structures, internal flow in subsea piping system and valves, scour around offshore structures, and free surfaces, flow, and wave kinematics. So that is a brief biography of our speaker. Here now is Professor Muk Chen Ong from University of Stavanger, Norway, to talk about ocean technology, trends and challenges, and research activities at University of Stavanger. Professor Muk Chen Ong, over to you.
Thank you, Professor Dato' Rafi. Yeah, so today is a very honor to have the chance to give a presentation to all you guys. Like to share the screen and see my presentations. So today I'll be talking about the ocean technology, trends and challenges. I will also introduce the research activities at University of Stavanger. So today for the ocean technology, the topics will be focusing on the activities in Norway. First, take a look at Norwegian Maritime Zone. Norway actually get the well mainly from the sea. This is because the Norwegian Maritime Zone is 6 times larger than the land.
Sorry, Prof. You forgot to share the screen.
I forget to share the screen?
Yeah.
Let me see. Can you see the screen now? Is it good?
Okay, thank you, Prof. Ong. It's okay now. Thank
It's
you.
okay. Sorry for that. Yeah, some technical problems here. Okay, I restart the presentations. Today I will present the topic of my presentation is ocean technology trends and challenges, mainly focused on the activities in Norway, and also I will talk about the research activities at University of Stavanger. And first, I give the introductions, talk about the Norway, and then the Norwegian actually get the wealth. Norway is one of the rich country in the world, and we get the wealth actually from the sea. And this is because the Norwegian maritime zone is 6 times larger than the land areas. And a lot of people know that actually Norway also get a lot of fortune from the oil and gas. So the maritime zone is very important for the value creation of Norway. First, I would like to also give an introduction about my university and the city. We are located in Stavanger. Stavanger is known as the oil and energy capital of Norway because most of the North Sea oil field is near to Stavanger. And our university is the 5th largest university in Norway, and we have 1,600 faculty, administration, and service staff. And we have 12,000 students, 1,560 international students, and 265 PhD students. And this is the campus. So we are a compact campus. All the faculty is in the same campus. And we are surrounded by the sea. And first, take a look at our faculty. We have several departments in the faculty. We have 7 departments. And my group is at the Department of Mechanical and Structural Engineering and Material Science. And so the marine group is one of the division in this department. So in the marine and subsea technology group, we have around 10 professors. We have full professor, associate professor, also adjunct professor from the industry, from the big company like Equinor, Subsea 7, yeah. And we also have the senior professor as a professor emeritus in the group. And we are running a PhD program, offshore technology PhD program, and we also have a direct master program 5 years and 2-year international master program in marine and offshore technology. And I'd like to let you guys know, actually the education in Norway is free. So if the student have finished the bachelor degree, they can go for this 2 years international master degree in offshore and marine technology. Then education is free. The student just need to pay for their cost of living. And look at our master program. So far for this marine and offshore technology, every year we have the evaluation. In 2018, our marine and offshore technology get the feedback from the student industry, and then we actually rank #1 in Norway for this all mechanical subject and mechanical engineering in Norway. And it means that our study program is very popular. Yeah. And the student, after they graduate, they can join all these company like Equinor, Aker BP. They even can be a PhD student in NTNU or our own university. Yeah, they can continue their study as a PhD student. And the PhD student in Norway is considered as a staff, so they get salary. And our marine offshore technology 2 years master program has a very strong connection and cooperation with marine offshore and subsea industry. So it means that normally the student will get the cost prices from the industry. So why I introduce this, because before we want to show the topics, we need to know what study program we have so that we can support the industry. So the industry and the university, actually, we are work hand in hand in Norway. So we work very closely in Norway. Okay, now we have the study program, and we have the teachers, and we have the students. And now we are trying to talk about the strategic areas. So in our university, we have the 5 strategic areas. First one is oil and energy. It's mainly focused on the reservoir and also other different types of energy. And we also have a strategic area called Ocean. Ocean, it means that all the activities, research activity, happen in ocean will be covered in this area, strategic area. And we have health and ICT and infrastructure, also safety. And I'm the person in charge of this ocean. Instead of myself alone, I create a center called OTICS with another 13 professors from 5 departments from the Faculty of Science and Technology, including the business school. So we cover technology, we cover the risk management, also we cover the economy, the business. So because why we do that, we also apply for a lot of EU funding, and now all the funding is talk about the technology, the impact factor, also how actually the work with the social science. So we need to have the complete team to tackle. And all these professors, they come from different areas. They're ocean technology, petroleum technology, wind technology, also business, also biomechanics. Yeah, but mainly we are working the topic related to oceans. Okay, now we have the people, we have the topic, then we are trying to see what kind of the tools we have. Okay, first we talk about our competence. And we focus a lot on the marine advanced computational job, the research work. So I have a group called Marine Advanced Computational Groups. And what we focus on marine operation and installation. You know, when we work with industry, when we train the student, we want them to do well in the industry. So all the simulation should be fast and accurate. So then we work on this marine operation and installation, which can provide a quick solution to the industry. And then next one, we have the high fidelity research work on marine CFD, marine computational fluid dynamics. And this is high fidelity. And then we use supercomputer and to run the case so that we got the high fidelity result and to support the marine operation and installation. Also, we have another team working on advanced mechanical engineering. This is mainly focused on material technology because in the subsea, the material are very important. So this mainly are 3 important line, what we are doing at the University of Stavanger. Okay, before we go into the topics, and then we like to see what kind of tools, because we need to have the tools to do the job. And we have this SIMA, it's called Simulation Workbench for the Marine Application, as created by my previous employer, SingTap Ocean, because I was the researcher in SingTap Ocean, one of the largest research center in marine technology. And we have this software called SIMA. Now the SIMA was managed by DNVGL in selling. I mean, sell through the DNVGL. We can do lifting operations. We can do the dynamic response of the fish cage, the large fish cage, semi-submersible type of fish cage. And also we can do the VIV for riser and pipeline. And also we can do fully coupled offshore wind turbine. So, and then we also work on a lot of open source. Okay, I would like to introduce this one we are working on. It's called Code Esther. Code Esther actually is created by EDF in France. They are using this code actually to do the nuclear plant design. It's not meant for marine technology, but you know, as a university, we like to have the open source so that we have a better control of the simulations. The previous one, this one is a commercial code. But as a Norwegian university, we can write the DLL because I worked in SingTap before, so we can actually modify the code together with SingTap, but not for the people who buy to purchase this commercial code. But for this one, Code Esther, you can change the code, you can modify. For example, this code is mainly built for nuclear plant design, but we actually transform it for marine technology. Like this is the dynamic response of the fish cage. We write the hydrodynamic code inside so that we can predict the behavior of the fish cage. And also we teach OCAFlex in our study program because OCAFlex is a very important commercial code for students to get a job. So we like to ensure our students will get a job. Then this is kind of using the OCAFlex to simulate the feeding batch. You know how the feeding batch actually supply the feeding tube to fish the fish in the fish cage. And also we working on Avagus, can do the bridges offshore bridges, also including the fish cage, and we also have ANSYS, and Open Botanica, also an open source to do offshore wind turbine. So this is to all these software are provide the quick solutions. Okay, now we talk about the high fidelity software, the code we are using. We are using OpenFOAM. OpenFOAM is open source CFD software. And for example, on right side, I show you two pipeline. Actually, this is a project I work together with Equinor, previously called Statoil. And then what we are doing is like we try to see two pipe interactions between them. And then actually the first pipe actually protecting the second pipe. You can see that the first pipe you can use the code, actually the standard, the DME standard to design the VIV, but not the second one, because the second one is subject to wake-induced vibrations. So then we need to use CFD to simulate the direct response of the second pipeline. And if you talk about the CFD, and then we would like to talk about the computational resources we have, because it's very important to have the strong computer and the strong cluster to do the job. And our institute has access to the NOTU high performance computing facility. It's a national infrastructure. It has 56,000 CPU, so we have the access. And we got the minimum 3 million CPU hours per year from NOTU, from these organizations. It means that I can run 345 CPU parallelly for 365 days. It means every day non-stop, every second I can run 345 CPUs. This is only minimum. If we need more, we can request for more CPU time. As long as, of course, we need to come up with a good publication and good research work. And ourselves also, I have bought a supercomputer cluster in our own university. We own 584 CPU cores for the small scale simulation. You can see this guy. He's very happy because every time I got the money for him to buy the computer, he's so happy because he likes to do Linux system, and then he helped me to maintain all these CPUs at our university. And mainly this when the PhD students are working on the big simulation, they're using the national infrastructures, the supercomputer in the national infrastructure. And then when the master student or bachelor degree, they are doing the small job, they were using our own small cluster, 584 CPU. Okay, so we have these tools. Okay, now we have the study program, we have the teacher, we have the students, and we have the tools. It's the time to look into the topics. Okay, I would like to show this picture because this picture actually covers most of the offshore activities in the sea. And you can see we have the deep sea mining, you have the subsea template, you have the riser, and then you have the LNG carrier, you have the offshore platform, you have the offshore wind, floating wind turbine, you have the fixed platform, you have the monopile and fish cage, including because Norway is going to build 7 large bridges to connect the island, so that you have this ferry free. You need to use the ferry to transport the car. So we're going to build the submerged bridges, tunnel, and all these actually all these activities are different due to the water depth. So in different water depth, we have different actually the activities. So we are going to build the areas based on all these activities. Okay, then based on the current situation in Norway, okay, we educate the student. What is important for the student? To get a job. They want to get a job. They want to have a good job. They want to buy a house, get married, and have a good life. So then, when we design the study program, we need to look at the market. So I look at the job market in Norway. So we define the 4 areas. After we have educate the student will get a job. So mainly is aquaculture technology because you know Norway is very strong in exporting the salmon. So aquaculture technology is important, and we have offshore and subsea technology. Norwegian is an oil and energy country, so this offshore and subsea technology is important. And now it's very popular is offshore wind because due to the political support, and then we have a lot of offshore wind activities. And Statoil is the company who actually operate the first floating wind farm in Scotland. Yeah, the Hywind Scotland Park. And so the fourth area we are focusing on this ocean technology is the field crossing, because we're going to build the offshore bridges. And these are the four areas. Now I'm going to show you the topics related to all these four areas, what we have done. Okay, first look at the aquaculture technology. And look at this map. All the red dot is one fish cage, and each fish cage has 200,000 salmon. And along the coast of Norway, okay, we have 3,714 fish cage. So it's quite crowded, and the Norwegian government is care about the pollution, the environmental issues. So they hope the fish farmer can move the cage offshore, so that to get a better quality of fish, and also the good to protect the environment. But in the offshore, then we have the challenge. What are the challenges? There are harsh environmental conditions. You have the larger wind, waves, and current loads, and it's very tough for the structures. And we need to design a robust structures. For example, like when we have the fish farming, the fish is inside the cage. What fish afraid? Fish will get a seasick also. If you have a large acceleration, like you sit on the flight, correct? And the flight actually changing the speed, like the acceleration or deceleration, and then you get sick, like want to vomit. It's the same like the fish. The fish need to have the very good environment to stay inside the cage, so that they can grow in a better way. Then you can get the better fish. So the design of the robust structures are very important. And also we talk about the operation and maintenance costs, because now we go offshore, and then the operation and maintenance costs will increase. All these are the new challenges we need to think about that. Okay, so when we are doing this aquaculture technology, we start with the conventional fish cage, which is a gravity-based fish cage. And this fish cage is not is light, and then the significant wave height they can withstand is up to 2 meters, and around 200,000 salmon will be inside. And we also work on this single moor system, so that this mooring is like one single point more. Then the fish cage can turn around the anchoring point, so that you get the better flow conditions. Okay, then we also work on the large fish cage, like for example, this cage is called half farm, and then you have 2 million salmon inside. Then we study how the dynamic response of the fish cage, and also we have the semi-submersible fish cage. We work on this also. All this work have been done by our master and PhD student together with the company. And also we are working on the feeding tubes and how this feeding tube actually feed the fish. You see all the fish cage here. Previously they used a boat to fish the fish, but when the boat come in, the propeller actually will destroy the net. And all these farm salmon, it's not good to let them to go into the environment, because they behave differently from the wild salmon. So in order to protect the environment, so they use the feeding tubes. But these feeding tubes will subject to fatigue problem. So we do a lot of dynamic simulation to study the fatigue and design and the response of the feeding tube, so that you get a better design for the fish farmer. And at University of Stavanger, we work together with Maritime Engineering. Actually, we have our own patent. We have our own fish cage. It's called module-based offshore fish farm. And we can, each cage, we can accommodate 400,000 salmon or cod fish even, because we use a strong material, so that we can raise a different type of fish. And one good things about this fish cage is that when the flow coming in, there's no blockage of the flow, so that you get a very good water quality in the fish cage. And even if some cage the fish is sick, and then we can remove this and treat the fish in a good way. So this is our cage called Muk. And we got the patent already, and we even carry out the model testing in the towing tank to study the behavior of the fish cage. Okay, and the next step we are going to do is to do the sea test. Okay, then another one that I'm trying to introduce to you is the land-based cage. This is called flow-to-tank, and we work with South Korea, Chongnam National University. And what we are doing here is like they have the fish inside the tank, but they need to study the oxygen level in the tank. So what we did is like we create the CFD model, include the transport equation for the oxygen concentration, and then we let the flow come in and study the concentration of oxygen of different areas. If in the empty tank with a good oxygen concentration, it means that when the fish was inside the tank, the condition will be even better. So this is how we have done the job for the land base. And even we work with the company, Remura, to improve the robot. This robot is to, the fish cage, when you are located in the sea, and then you get a lot of algae, and then the biofouling. And for this robot, you can clean the biofouling because you have an AI can detect the biofouling and clean them. And also this machine robot can actually seal the net. If there's a leakage of the net, it can detect and repair the net. And we also work on the salmon lice. The sea lice is a big threat to the salmon. And we can do the ocean modeling because the sea lice actually flow together with the flow, the wave and current. So you can see the sea lice is very smart. And then they attack the fish, they attack the fish head, but not the fish body. Because in the Norwegian fish farming, they use another type of fish inside the cage to eat the salmon lice. But the salmon lice is very smart. It moves to the head, so that then that kind of fish, like called leptofish, have no chance to eat the sea lice. But so the sea lice is very important. We need to have a good flow condition. Then we can introduce the sea lice as a concentration and put in the ocean modeling, combine them, and then we know where are the sea lice. And even we can study the environment, the DNA. Every fish, they have their own DNA. Like for human being, we have the hair, we have our skin, all this, and then it's called environment DNA. And then we can use the environment DNA of the prawns of the fish as a source, and then we can know where are the fish by doing these ocean modeling simulations. Okay, and University of Stavanger, my team is also part of the research partner in this Smart Aquaculture Research Centre in South Korea. The principal investigator is Chongnam National University, so we work together with them. We got the research center, and this research center starts from 2019, and total we have around 6.2 million US dollar for 7 years. So we work on different types of the aquaculture system. Okay, so I have complete the part for the aquaculture technology. Now we go to the next area, which is offshore and subsea technology. Okay, pipelines are very important for transporting the oil and gas. And so you can see these two pipelines, we're using the 3D simulation, large eddy simulation to study the flow around pipeline, so we can see how the flow interact each other. And also we study on the FSI, fluid structure interaction problem for the piggyback, to have the better design of the piggyback. And even this work has been created for new energy converter for 5 kilowatt, and it's called VMAX. It's our own invention called Vortex-induced motion energy converter. And we also study about for the flow around the faultation, the offshore faultation. This is gravity-based structures. We study the flow around the faultation, and also we have the open source set form for this scour erosion. We are working on the set form to predict the scour erosions, and we also have open source. We have already published this open source. Is created by University of Stavanger, and is for the liquefactions. So you have the wave coming, and then you can change the pressure upstream and downstream of the faultation, and then you can create the internal flow in the soil and can weaken the soil so that the faultation can sink. So this is very important for us to predict the liquefaction situation beneath the offshore faultation. And also we work on the optimization of ROV shapes, and then we study how this ROV have a better performance in the subsea environment. And for example, this ROV, that time we got this job research study. The ROV cannot go straight; it always go one side. And then we use the CFD to study the flow around the ROV, and then we advise the partner, say this part is not good, we can modify it based on our numerical simulation result, and the ROV actually can go straight very well. And also we study the internal flow, the multi-phase flow, internal flow in the pipe by Brian T, or the internal flow. And we study the subsea cover. The subsea cover actually is to protect the pipeline and the subsea module. And we study the drop object, how the drop object actually hit the subsea cover to protect the subsea module inside the subsea cover. And we do lifting operations using the numerical simulation. And also we do the throw door. You know, when we have the fishing gear and the throw door, and we hit the pipeline. Then we study the impact force also. And we also study in the subsea area, we have the high pressure. Also, we study the material, the crack propagation, also multi-phase flow, and the ROV, how to actually improve the thruster. So we use the Open Mathematica to study the thruster, how we can make the best configuration for the ROV. And also, we also working on some special tools to remove the damaged pipeline. For example, you have the pipeline damage, and we cut it, okay, and then you can put this removable tools, and then we study the contact mechanics so that we can lift the damaged pipeline, which been cut and lift up from the sea. And also we study the high pressure vessel for the subsea equipment. Okay, now I would like to introduce another project we work with Equinor. We carry out the prelim study for Equinor. This is a subsea shuttle. It's a submarine. And this submarine is a subsea shuttle is 135-meter long and 17-meter diameters. And what the purpose of this shuttle is to transport the CO2. Okay, all this subsea shuttle is will be fully autonomous in the sea, and then you can get this video from the YouTube. And then they transport the CO2 and then back to the reservoir so that we can get enhanced oil recovery. So this is the subsea shuttle we work, and then we work on the design and also the prelim design, the baseline design. Also, we work on the 3D simulation. Use the hydrodynamic simulation, CFD simulation, to optimize the shape of the subsea structure, subsea shuttle. So this we work with the Equinor. Okay, so that cover the offshore and subsea technology. Okay, now we come to the next topic, is the offshore wind. We have done the monopile, the bottom fixed monopile, and also including the combined monopile and jacket bottom fixed wind turbine. But for the bottom fixed, the highest, the largest water depth is up to 60 meters. So beyond 60 meters, we need to use a semi-submersible. Also, we work on semi-submersible. And also, we work on different types of the wind turbine, including the vertical axis wind turbine. This is called horizontal axis wind turbine. This is called vertical axis wind turbine. Also, we also work on different types of floater with the spar, semi-submersible, also PLP, tension led platform. Okay, we also combine the offshore wind together with the wave energy converter. You know, as a wave energy converter standalone, it's very difficult actually to get the profit, because the cost is high. So we attach the wave energy converter into the offshore wind turbine. And we found that we can reduce the construction cost and also increase 7% of the wind energy. So I mean, the total energy from the wind, this wave energy converter attached on it, we can get 7% extra energy. So this is a very good gain. And we are working on the breaking waves CFD simulation to study the impact force of the breaking wave on the monopile and any offshore structures, even the floating turbine. floating floaters. And also we study on the flow around the faultation to study the scour erosions and the lifting operation for the wind turbine installations. Oh, yeah. Okay, we also work on the drivetrain, the gearbox, everything inside the wind turbine, and combined with the robot analysis. So we study the whole wind turbine response, and then we go in detail into the drivetrain, the gearbox, and see how we can actually have the good design on to get the best energy out from the offshore wind. And this is a project we work together with Rosenberg, and Rosenberg is owned by Wally Parson in Norway, and they have the new invention is called the floating storage of wind turbine. You can see this floater is floating, and it's very thin with the truss-based structures, and they are flexible to move around. So we work on the simulation for them, and now we have one PhD student from the support by the Rosenberg Wally to work on this topic. So this is a very new project. We started this project in February, and then be able to actually come up some solutions for this design. It's very challenging. They're also going to put a lot of wave energy converter on this floater. Okay, that covered the offshore wind. And now we come to the last area, which is the fjord crossing. And as I mentioned earlier, Norway is going to build a lot of floating bridge to connect the island. Then we can do the fully coupled simulation of the bridges. And we also study the aerodynamic to optimize the shapes of the deck. You know, this is the cross-section view of the deck. And previously, I worked on this two deck. You know, when the two deck actually close to each other. Normally, for the bridge, the deck are side by side, so that you can have some shielding effect, so that you have less vibration. But some of the bridges are designed like up down. You know, up is the train or down is the car, but normally they have a large distance. When I do on this research, I try to put two decks very close to each other, and a lot of people tell me that this is not possible because you can create a lot of vibrations because there's the contraction of flow between the two decks will cause the vibration. But in China, in Dalian, the Xinghai Bay Bridge, you can see that they put the two decks very close. You know, the human beings are very smart, so they put a lot of stiffener actually to stop the vibration. But another problem is that with so many stiffener, you can create another problem is the scour erosion, the faultation. So yeah, you need to use a scour protection for this design. And also we work on the turbulence modeling. Since we want to design the bridge, then we need to know the wind, the turbulence. Then we do LiDAR measurement also to study the turbulence effect, and then we use it as an input for the design. Okay, basically I've covered the four areas. I talk about our university. I talk about the professor, the teachers. I talk about the student, the study program, and talk about the software, and talk about the area, the focus, the activities, and the strategy area focus on in the ocean technology. Then my summary is that I think our work is trying to cover most of the activity in ocean. So yeah, thank you very much for your attention. I finished my presentation. I show you this picture. This is a public rock. You know the Mission Impossible 6. They have some scene in this public rock. So it's in Norwegian we call Proceedings. So this is I took this picture by using my mobile phone. So you can see the scenery is very beautiful. So if you guys want to visit Norway, you're welcome. Yeah. Thank you very much. Hello, I finished my presentations. Any questions on the floor? Henry, your microphone is mute.
Yes, thank you, Professor Ong, for the very interesting, very informative presentations on the Norwegian experience, and especially from the experience in the University of Stavanger in the ocean engineering research. And normally in our area of the ocean engineering, the research activities from Norway is always in the very advanced and leading positions. And I believe that many of the ideas they will bring a very significant impact to the rest of the world. And I can see that such like some activities and research capabilities in University of Stavanger, especially in the simulation, they can be proactively and to be combined with our experiments capability in UTM. So I would say that we are looking forward for many potential opportunities to collaborate together. And I am happy that we probably will have some viewer from the Malaysia local industry, and maybe they have also will see some interesting point from the presentation as well. I would say we will have some Q&A. Okay.
Feel free to ask any question. I do my best.
We have some Q&A sessions for now, and maybe we try to give some maybe we can start with any questions from our audience floors. Okay. All right. The first question is from David Farihas, Ernest. Interesting. Is the catch shark-proof? Just curious.
Yes.
The one.
Yeah, because I have a friend in China, and then when they decide it's called Deep Blue One in China, the cage was attacked by the shark. And then after that they repaired it, and then they have the second version, very strong. The shark cannot have no chance. So you need to protect the fish. You know all these fish. You know how much is it? Like the big. Okay, 1 kilo of salmon you can sell like 25 ringgit. So in Norway, so let's say you have the one conventional cage. Then you have the 200,000 salmon, and each salmon can grow up to 5 to 6 kilo. Let's say 5 kilo. Then you have 1 million. Then you have 25 million ringgit, and you take away the cost of the food feeding. Then each cage the fish farmer each cage can earn 12.5 million ringgit after 1.5 years. So I think for the cage near to the shore, they do not have those big fish, so to attack the salmon, so it's okay. But when you go to the offshore, then you need to have all this protection against those big fish.
Okay, thanks. So we have the second question is from our another viewer, Ikai. Ikai asks, can we have the slides of the presentation? Okay, maybe later on I will discuss with Professor Ong.
Yes.
And are these sectors, markets, and availabilities applicable to Malaysia and Singapore as well? So that means probably is it the technology that can be implemented to Malaysia or Singapore region? Yeah, Professor, please.
Yeah, Singapore is because I graduated from Nanyang Technology University of Singapore. So Singapore is a small country, and Singapore, but the NUS actually have this ocean basin. Actually, they're going to do a lot of research for the world. So they're focusing on the research. But in terms of building the offshore wind turbine and the fish cage, I don't know whether they have space or not. But for the fish farming, actually it's possible for Malaysia. So we can use the technology of fish farming to have some expensive fish. You can get the profit actually, and also we can improve the production of the fish farmer in Malaysia. And the offshore wind, then you need to see how good the wind resource. In Norway, in the North Sea, we have ample space, so we can have these wind turbines. But in Malaysia, if in the South China Sea, if let's say you have the big space, and then the offshore wind may be possible. But you also need to consider whether the country need this energy or not, because I know Malaysia has a lot of oil and gas. Like for example, Norway, actually we don't even use our own oil and gas. We export all the oil and gas. You know the reason? Because the major energy supply for Norway is hydropower. Because we have a lot of mountain, and Norway is around 5 million people, around 5.2 million people. So the energy is a lot already. So I think our electricity unit is cheap. But when we have oil and gas, we have offshore wind. We try to export the energy to get the money.
Okay, thanks, Professor, for this question. The answer for this question. Yeah, we have Carol Ng from. I remember Dr. Carol Ng. He is our colleague from UTP, University Technology Petona. Thanks, Carol. Carol asking a question here. Here was the oil price drops impacting on offshore engineering research in Norway. So is it that will bring any impact as well? I believe the full question is like this. Yes, please.
Yes. Yeah, of course, the oil price drop will have some impact because we export the oil and gas, including the fish. Even the coronavirus actually caused the problems. But so far, I think Norway is quite okay. We cook very well because the government actually has the strategy very early. And now the government actually invest a lot of research money in because Norwegian has already earned a lot of money from the when the oil price was high. And now we are selling Brent oil. So the Brent oil price is around the $43 US. I think the price is still okay for Norwegian. So we are quite okay. Yeah.
Okay. And the next question. I think the speech from Professor Ong is very interesting. So we have a lots of questions coming. Okay.
As you wish.
Thanks for your very informative thoughts. I want to ask, what is the possibilities to in working as an academic in University of Stavanger as a Malaysian? So what are the challenges and how can we equip ourselves to be inheritors?
Yeah, so academic. You mean that
career.
As an assistant professor, associate professor, and full professor?
I believe as an academician,
academician, or you trying to say that you want to do a PhD? Can you just?
I think maybe we can try to.
We can talk both. Okay.
In general.
Norway is a non-immigrant country, so our main language is Norwegian. I speak Norwegian. So I have been in Norway 15 years after I left Singapore. So it's quite challenging to be an academic. The academic staff. So we need to work a lot, and then Norwegian are very smart. They are very intelligent. So it's a very competitive. So as long as you work hard, you have chance. Because I become a full professor already. I even become the Norwegian Academy of the Technological Science. So you just need to work hard. And if you talk about the PhD, yes. First, indeed, recently I'm going to recruit one Malaysian as my PhD. Most likely, I will recruit one. But if in order to get the PhD position, you need to have master degree. We cannot accept direct PhD. So bachelor degree, you cannot apply for the PhD position in Norway. I think in Norway, the salary of the PhD, I think, is the highest in the world. We have a very high salary. I think after tax, because you can find the information online. I can tell you after tax we can have around close to 13 or 14,000 ringgit every month after tax. So I mean you're protected by the social security also. Normally the PhD is 3 years, and so far our PhD actually produced a lot of publications because it's very competitive. Because we are very strong in marine and offshore technology. So, but you get all the resources like supercomputer lab. Actually, I did not show you. Actually, we have a channel here. A tank is a 25 meters times 3 meter country. We're going to modify it for different purpose to do the testing. So, yeah.
Okay.
But the master degree is free of charge.
Okay.
So I have taking 25 students every year, 25 to 30 students, and the international student we have 15 places, around 15 places, and they are free of charge. You don't need to pay for school fee. You just need to pay for your own living, your food, your accommodation, and you can stay in the university dormitory. If you don't know, you just go to Google me and get my contact. You can send me the email and we can talk about it. Yes.
Okay, thanks. So, because I believe that Professor Ong only one PhD, so you can complete your master in UTM first.
Yeah, also we can do it with.
If you are good enough, then I can recommend you. Okay. So from our Professor Omar, from Professor Omar Jacobs, are there already ocean energy tidal currents or wave energy installation in Norway? Commercially, what specific devices are being studied in UIS?
Yeah, for the tidal current and wave energy, we have some, but not big scale because it's basically testing. And then because the cost is high, Norway already get a lot of energy from hydropower. Even we don't actually use our own oil and gas. We sell it to get the money because the hydropower is the mountain, the reservoir is enough to get a lot of hydropower. So recently the government actually tried to build I think we see the wind as the future. The wind actually have a better chance because the cost is lower. The LCOE, the levelized cost of energy, is lower. And about the wave energy converter, now what we are trying to do is to combine with the wind. Actually, I have proposed this to Equinor. So we are going to actually put the wave energy or tidal current energy converter like our VMAC, Vortex-induced motion energy converter, attached to the wind. Yeah. And then if you want, then you can reduce the cost, and then you have chance to actually get back the profit. Because when we do work on this, we talk about the profit, right? Because the company want to invest, they will think about whether they can earn the money or not. If cannot earn the money, they will not do the job. Okay, and so this is important to look at this. Yeah. So devices for the current base is we have a VMAC, Vortex-induced motion energy converter is our own patent. We're working on this, and then for the wave energy converter, we work on OWC, and also the working on the torus, attached to the spar so that the torus will move.
Yeah, Professor Ong, for your information, Professor Omar Jacob is our research fellow in Marine Technology Center, and he is a prominent professor, especially in offshore wave energy conversion. So I believe in future, maybe they will become probably the Norwegian and Malaysian collaboration, especially in area. Yeah. The next question from.
I can answer a bit more. The wave energy converter and the current base energy converter. Okay. What you can do is, because normally the energy is not so large as a wind, okay? But they are not big. If they are not big, like for example, the VMAC is only 2 meters, not big. You can attach to the feeding barge for the fish cage. And then, because if you want to move the fish cage to offshore, then you cannot use the power cable, correct? To supply the electricity. But you can use this wave energy converter or current-based energy converter to charge the battery. So you can put a lot, like huge battery on the feeding barge, okay? And then charge the battery, because for each feeding tube, I think the usage of the energy is 22 kilowatt. So you can use the battery actually to pump the food to the fish cage. So you can attach all this lower cost. I think you can get some profit there.
Yeah, I think we will have a further discussion all together later. And from the next question from No Hayati, who said, so how Norwegian University made smart partnership success works in research, especially towards their nation needs and impacts to global opportunities?
Yes, I'm the leader, one of the strategy leader in this university. You know what I did? Actually, I go to when the student look for the job, they have a job market website. And then it's very easy. You just type the keyword in the job market website. You get some good job market website, correct? Job market website. And then you type the keyword. Then you can see how many jobs. And then we are talking to the industry partner every day almost. Like yesterday, we have the 2 or 3 meetings with the companies. we work very closely with the company. Every of my master student and PhD, they have a course supervisor from the company. So we work so close because we know that the student need to get a job. And I can tell you something, if you get the master degree from the University of Stavanger, the last few years, 100% of students get a job. 100%. And I follow up with the student very closely. I call them and then talk to them, how was the situation in the market. So in order to attract more students and work well in the industry, including the research funding from the industry, then we need to know what industry wants. So this is a very key thing we're going to do, is work with industry. And how to make the research better, and then it's our job, it's a researcher job. And then for each topic, we go deeper inside to have publication. So you can see, you can check the Google or my publication list, you can find that I publish a lot of papers with the industry partner. So sometimes the co-author of the paper are from their industry partner. So they're willing to actually publish together because it's an advertisement for the industry partner. It's a free advertisement for the company. So we do a lot of strategy like this to build the good collaboration between the university, the research, and the company, and the job market. Yes.
Yeah, I think there's very it is very good strategies, and in fact we also have quite similar way. We name it as the PPRNs, public-private relationship networks. We can work together so many things. And okay, I think that probably is last question. Maybe is from Mr. Ali Hassan Muhammad Murik. Okay, interesting thoughts, Professor Ong. Do you have mathematicians collaborating with you in ocean technologies? Maybe he is a mathematician. Have you been involved in solving undersea cable laying problem? Thank you. Wow.
Yes, the first question is very good. You know, I came here as a civil engineer from the Nanyang Technological University as the bachelor and master degree. And then, you know, when I come to Norway, you know, the first thing I'm doing, take mathematics. I take a lot of mathematics. I learned all the numerical methods, the final element method, because I found that when I do the CFD, computational fit, I make numerical simulation, I need a lot of mathematics. And I can tell you now, in my teams, there are a lot of my researchers are applied mathematics. Mathematics is very important for numerical simulation, for coding, everything. Okay, so I like the mathematicians to work with us, especially applied mathematics, because even I still go to brush up my mathematics. And for the laying pipe,
laying, yes.
The pipe laying, actually, we have just last year, I think we have one master thesis working on the lay the pipe with piggyback. No, the laying the pipe you can simply do by Aquaculture or CMO reflex or Simla to do the job, the software. And we look for even more advanced, how to lay the piggyback. You know, because when you lay the piggyback or strike riser and the pipeline, then you have your hydrodynamic coefficient will be different because it's not circular cylinder, it's asymmetric. Yeah. So then we even work on that. So yes, I do that. You can contact me. You know, you just simply find me from the Google. You can contact me anytime you want, and we can work together.
Yeah.
No problem.
I think it's also possible if we can just want to make direct, or you can also contact MTC. Then we have a good collaboration with Professor Ong, so we can also reconnect you to Professor Ong as well. Don't worry. Okay. Then we have the questions from Masakoto. Thank you very much for your interesting lecture. So any new research activity on spill oil remediations in the ocean in Norway? Once I visited Sintef, okay, our area. So which working on bioremediations on spill oils? It was long ago. Okay, Prof. Ong.
Yeah, for us, we don't do the bio part because we are marine technology, but we can do the oil spill. When I was in Singapore, I was in this Maritime Research Centre. But now, I think the center was no longer there. And that time, we actually work on a lot of oil spill. We use GIS to detect the oil spill, image processing. And we can use the offshore modeling, all this, to study how the oil spill will move around the area. with ocean modeling. It's possible to do that. But how to study the bio part in the oil spill, you mean the oil itself, it's not my area. So I do that. But in terms of ocean modeling, the GIS, distribution of the oil spill, it's possible to do that.
Okay. Yeah. So another question from Fauzan Abdullah. How serious Norway spends for R&Ds? How about engagement between universities and industry there?
Yeah, Norwegian government is very serious to spend the R&D. Because in our country we have not many people, 5.2, and then the Norwegian actually is selling the technology. So we have very advanced technology in ocean, in offshore oil and gas, in ocean technology. So every year we have a lot of call for the research call for funding. Actually, yesterday I have a big talk with several companies. We're going to get money to hire, because as you know that the Norwegian also pay very well, pay the PhD students very well, the postdoc. So I think Norwegian government spend a lot of money in the funding to support the research. And industry, as I mentioned, I talk to industry almost every day, and I have many students in the industry. Most of my students actually they become senior engineer, they become principal engineer. Some even my students become the associate professor and professor. So actually we keep in touch very closely.
Okay, so I think we still have a lot of questions, but due to the limitation of times, so we're only able to receive the last one. Just curious, ratio of male to female students in Stavanger University.
That's on the study program. Of course, in the engineering subject, normally we have more male and female, correct? But it depends, among my PhD students, 2 years ago, I have more female than male. But this year, I have more male than female. We are working on numerical simulation. So the female student, of course, is welcome. And I even got one student, she got the Marie Curie Core Fund scholarship. She's a female. I think she has finished 8 journal paper in 3 years and 3 coastal engineering journal, very high quality. So I think to me, I don't look at male or female. I look at the student, how good he or she is.
Yes. I hear a very good answer.
More female than male.
Okay, thank you so much. Thanks a lot for very interesting and very informative, yes, very impactful Q&A discussions with Professor Ong. So I would like to thank you for all of you to join us in this distinguished lecture series today. So to the viewer, please stay tuned with us for the incoming lecture series. Share and like our Facebook at Faculties of Engineering, UTM. So I would like to pass the floor again to Professor Rafiz for the closing remark. Prof, please.
Thank you, Henry. Thank you for chairing the session. And to Professor Muk Chen Ong, our deepest gratitude to you for sharing your knowledge with all of us. Thank you for accepting our invitation, and thank you for sharing your expertise on this issue. We hope that our collaboration will continue in the future. And to all of you watching this distinguished lecture series, wherever you are around the globe, thank you so much. Do share this video to all your colleagues and friends. Stay tuned, because we have a lot more lecture to share with you. Thank you for watching. I'll see you in our next series of distinguished lecture. Bye-bye now. Thank you.